we're going to move on to problem 6. Which of the following reaction For the following reaction, predict the signs of delta H and delta S. So delta S is entropy or disorder of a system, and H is enthalpy or energy stored in a system. So we'll look at our and estimate our signs from our reaction. So from our reaction, the best way to estimate disorder is by counting how many products versus reactions we have. Disorders, I like how things are not bunched together. If you think of a room that's messy, everything's all over the place. But a thing that's very ordered is something that's all like close together. Everything's where it's supposed to be. Everything is where it should be, and it's all one thing. So let's say in the beginning you have two things, and they're separate and unorganized, and then when you go to one thing, you become more ordered because they're together instead of that. So usually you can say that if something's becoming more disordered, you're making more of that thing. So if you had two things in two different places, that's more unorganized than one thing in one place. So you can say that this is actually becoming more ordered, and if it's becoming more ordered, that means disorder is decreasing. So we have a negative sign for delta S. So it's less than 0. That'll mark off C, A, and E. So now we have the question of energy stored. Okay, so now we have a double bond versus a single bond. Single bonds are usually lower in energy. So we go from something as high energy as a double bond to something low energy. When we go high to low energy, we can draw that out on an activation curve. So this product had high energy, and the reactant has low energy and more stable. This is a favored reaction, and this is exergonic. When something's exergonic, it's favored because we're going to something that's unstable, high in energy, something that's stable, low in energy. So our delta H here is the energy difference from our product or our reactant to our product. So this space right here, use a better color. This right here is our delta H, and we do reactant or products minus this, so this would actually be a negative number in this case. Because it's exergonic, you have a negative. That's also, you should know that exergonics are negative when favored. Gibbs free energy is negative when favored. So we can say that this problem, because it's exergonic and coming from something that's high in energy that has a double bond. So we can say that our answer is D.